When you're working with similar triangles, it's quite straightforward to find unknown lengths. There's two common methods used. Either you can work out the scale factor to get you from one triangle to the other and multiply by that, or you can use the ratio method, which is basically saying this is to this as that is to that. Let's use both methods to do both these examples so you can see how it works. Now, these two triangles are definitely similar. I can tell because they've both got this angle labelled with the cross and the angle labelled with the curvy line. Now, if two angles are the same, the third angle must also be the same, whether it's labelled or not, because they're triangles and all three angles add up to 180. So if these two are the same, the last one can only be one thing. Now, that tells me that if the angles are equal, the sides must be in proportion. So I can say, all right, this is the smaller triangle of the two. How much smaller is it? Now, very important you get the corresponding sides lined up. I can't compare the 7.2 with the 2. I need to compare the 8 with the 2. And the reason that I know is because this 8 here is opposite the the angle with the x in it. And the side that's opposite the x on this triangle is the 2. So the 2 and the 8 are corresponding sides. So going from this triangle to this one, I can see that this one is only a quarter of the size because 8 times a quarter is 2, or 8 divided by 4 is 2. But with the scale factor method, we want to multiply by the scale factor. Now, you might say, why is the scale factor a quarter and not 4? Well, going from this triangle to this triangle, the scale factor would be 4. But I know more about this triangle, and I want to know something about this one. So it makes sense that I'm going to start with this number, multiply it by something to get this. So if 8 times a quarter is 2, then 7.2 times a quarter must give me x. So the first method, find the scale factor, which was a quarter, and multiply by it. So we have 7.2 times a quarter, which gives me, what, 3.6, 1.8. So I've got 1.8. Now, how would you use the ratio method? Well, you work out which sides are corresponding. So I've worked out the 8 is with the 2. Now you can say 8 is to 2 as 7.2 is to x. Now that's using that is to. But as we've already seen, when you have this situation, it's exactly the same as saying 8 is to 2 as, your as becomes an equal sign, 7.2 is to x. And this is exactly the same as saying 2 is to 8, the way x is to 7.2. Notice how these two statements, each time both sides have been flipped upside down. How do you know which way to go? Well, the reality is it doesn't really matter. It's slightly easier to solve if you have your x on the top of the fraction, because your next step to get the x by itself here is just to multiply both sides by 7.2, which is nice and easy. Now you'll notice that what you're multiplying 7.2 by here is basically just a quarter, isn't it? 2 over 8, that's exactly like what our method was like up here. But we never had to stop and say, gee, what's the scale factor? We just said this is to this as that is to that. Now we had to make sure that if we were using the little triangle first, then both of the little triangles things have to be on the top, and both of the big triangle sides have to be on the bottom, and we had to make sure we did the corresponding 2 is to 8 as x is to 2. Sorry, 7.2. But there's other ways you can write this. You can also say 2 is to x as 8 is to 7.2. Here I've just made sure I went from one of the small triangle sides to the other, and then I started with the corresponding one, so that you can see that here the 2 and the 8 are corresponding and they're both on the top. Here they are both on the left, and the x and the 7.2 are both on the bottom. This one could also be flipped upside down. I could say x is to 2 as 7.2 is to 8. And again, I've got my corresponding sides together on the bottom and together on the top. Now, 4 different statements could be written here, and I don't mean to confuse you, but I'm showing that there's 4 ways to write it, because no one of them is more right than the others. And if you're working on this with a friend and one of you has different working from the other, you need to learn that that's okay. There's heaps of flexibility there, as long as you've shown your working and your answer is correct. The one I prefer to use is probably one of these two, because it has the x on the top. And so the key method to solve it is just to, in this case, multiply that side, so you'd have 2/8 times 7.2, or over here, you'd say x is equal to 7.2 over 8, and then you'd multiply that by the 2. Same difference, you're doing the same thing in the end, and you're going to get 1.8. All right, so this is to this as that is to that. This is to this as that is to that. Either way will work. All right, so let's have a look at this blue example. This one's a little bit different because there's no nice numbers. Now, when I say nice numbers, this scale factor method up here kind of relied on me knowing that 8 divided by 2 is 4, or 8 times a quarter is 2. They were nice friendly numbers. And then the other numbers weren't quite so round, but I could still work with them because I had these lovely round numbers. Now, when it comes to this one, let's have a look at what we've got. We've got common angles at the top, and we've got this one with the cross on it down the bottom, and then a right angle. So they're definitely similar triangles. When we say this is to this as that is to that, and I'm going to jump straight to the ratio method with this one, because I can't spot any numbers here that sort of line up. The only number I've got on this triangle is 6.7. Now, I'm not great at my 6.7 times tables, but I'm pretty sure that's not going to go evenly into 16 or into 5.3. So this method's the one I want. It says here find x to 2 decimal places, and that's making you curious possibly, because you're thinking, won't it be a nice round even number? No, it won't, but we can still figure it out. Okay, so which are the corresponding sides? Well, this 6.7, we'll start with the x. Always write down the x first, because that's the one you want to find. The x, if we compare it to the other corresponding side, now it's the hypotenuse, and the other hypotenuse is 16. So x goes with 16. X is to 16 as the other side, 6.7, again starting with this triangle, because I started with this triangle, so I have to start with it again, is to 5.3. Okay, I could have also written x is to 16 as 6.7 is to 5.3. I'll get the same answer. All right, solving this now for x, I've got x divided by 16, so I want to multiply both sides of my equation by 16. That'll give me just x over here, but over here I'll have 6.7 over 5.3, and I have to multiply that whole thing by 16. Now, when you take out your calculator to do that, what you're going to find is that the answer is 20.2264159. It keeps on going. Now, they've asked for 2 decimal places, so I'm going to round it off to 20.23, and this is in metres. And that's perfectly okay to know that we have to round it off. After all, life is messy, and lengths of triangles are not always a perfect amount, and you can only ever really be as accurate as what your measuring tape is anyway. So this is a perfectly acceptable way to do a question like this.